For feeds showing the same number, may still be one observation copied 4 times. 4 fresh prices may still be incomparable because one is an adjusted close, another is a midpoint, and 2 are last trades. So the tempting move is the wrong one. Taking the median of whatever numbers arrived treats agreement as arithmetic when agreement is really a question about evidence. The useful question is not what the median of these numbers is. It is which observations are eligible, which independent owners agree, and whether quorum survives the disagreement check. This is a data quality diagnostic. It does not estimate fair value. We will build the price source consensus check as one auditable decision. You will learn to gate every candidate row on contract, on clock, and on owner before any statistic runs. Then we compute a center and a robust band, apply an explicit tolerance policy with a cap, handle the zero deviation branch on purpose, and recheck quorum after outliers are removed. The result is one of 3 statuses, and 2 of them return no price at all. We finish by replaying 24 synthetic decisions in Python and TypeScript. Mad outlier filter teaches the underlying statistic. Here we build the decision around it. Eligibility comes before statistics, and the first gate is the contract. Every candidate row must match the same instrument, the same currency, the same price type, the same adjustment convention, and the same session. Those 5 fields are compared exactly. The check never converts a currency, never aliases a symbol, and never quietly turns an adjusted close into a last trade. Those are different contracts, even when their numbers are almost identical. In a fixture, one source reports a currency of euro, and another reports a price type of adjusted close. Both are excluded as contract mismatches. The field that failed is named, and the raw row is left untouched. The second gate is the clock. Every event time must be no later than the decision instant and no older than the configured freshness limit. In the fixture, that limit is 500 milliseconds. A row stamped after the decision instant is not merely late. It is impossible, so it is excluded as a future event rather than trusted. A row older than the limit is excluded as stale. Both exclusions are recorded against the source that caused them. Notice what this gate does not do. It does not repair the timestamp, it does not extrapolate the price forward, and it does not borrow freshness from a neighboring snapshot. The third gate is ownership, and it is the one people skip. A quorum unit is an owner, not a label. If 2 source identifiers map to the same owner, both of them are excluded, not merged, and not arbitrarily picked. Choosing one silently would add a source selection policy to a consensus algorithm, and that policy would be invisible in the output. In the fixture, 2 labels share one owner. With 3 other independent sources present, the snapshot still reaches consensus. With only 2 others, eligibility falls to 2 independent owners. The minimum of 3 is not met, and the answer is insufficient sources. Names alone never prove independence. Now the decision map. After the gates, count the surviving independent owners. If that count is below quorum, the answer is insufficient sources and no price is returned. If quorum holds, compute the center and the band. If the band is wider than the configured maximum, the answer is disputed and again no price is returned. If the band is acceptable, partition the sources, then check quorum a second time on the alias alone. If that second check fails, the result is disputed once more. Only when both quorum checks hold does the answer become consensus. Availability, agreement, and a final value are 3 separate decisions. Now the statistics on eligible prices only. Take the median of those prices and call it the center. Take the absolute distance from every price to that center, then take the median of those distances. That is the median absolute deviation. Divide it by 0.6745 to get a robust scale comparable to a standard deviation under a normal model. NIST defines that scaling. It does not assert that source prices are normally distributed. Now substitute the worked example. The floor prices are 100.001, 100.009, 100.014, and 100.380. The center is 100.0115. The deviation is 0.0065, and the robust scale is about 0.0096. The band itself is engineering policy, and it is declared, not discovered. Applied tolerance is the larger of two things, an absolute floor in price units, and the multiplier times the robust scale. In the fixture, the floor is 3 cents, and the multiplier is 3.5. A source is inside the corridor when its distance from the center is at most the applied tolerance, and the comparison carries a tiny epsilon, so a value sitting exactly on the boundary stays inside under binary floating point. The policy also sets a maximum allowed tolerance. If the applied tolerance exceeds that cap, the snapshot is disputed before any source is classified. The cap stops an inflated deviation from widening the corridor until incompatible clusters look like agreement. Put the worked example through that corridor. With a robust scale of about 0.0096 and a multiplier of 3.5, the adaptive tolerance is about 0.0337. That is larger than the 3-cent floor, so the adaptive value is the one applied. Now measure each source against the center. A sits just over 1 cent away. B and C each sit a quarter of a cent away. D sits more than 36 cents away. A, B, and C are inliers. D is named as an outlier, not deleted and not repaired. 3 independent owners remain. Quorum holds a second time, and the consensus price is the median of the inliers, 100.009. Zero deviation is a defined branch, not an accident. If at least half the eligible prices equal the center, the median absolute deviation is 0. The algorithm does not divide by 0, and it does not borrow a scale from an earlier snapshot. It sets the robust scale and the adaptive component to exactly 0, so the applied tolerance is exactly the absolute floor. With a floor of 0, only prices equal to the center are inliers. With a floor of 3 cents, a price sitting exactly 3 cents away is included because the boundary is declared inclusive. That case isn't a fixture, and it carries its own boundary test in both languages. There are 2 different ways to be disputed, and the fixture contains both. On the left, 3 owners report 100 and 3 owners report 101. The center lands at 100.50 and the deviation is 50 cents. So the adaptive tolerance is about 2.59. That is far above the configured maximum of 0.15. So the snapshot is disputed before any source is classified. On the right, only 3 sources are eligible. 2 agree within a cent. The third is far away, and the corridor is narrow enough to remove it. But that leaves 2 independent owners, so quorum is lost after filtering. Neither result claims that a cluster is wrong. Now the part the statistic cannot see. Independently branded labels can share one undisclosed upstream feed, so 3 sources can be one source wearing 3 badges. Several genuinely separate systems can apply the same wrong corporate action and agree on the same wrong price. A synchronized repricing across the whole market can be entirely correct, while a stale consumer labels it an outlier. And the floor and the maximum are expressed in price units, so they do not transfer automatically to another currency or another price scale. The ownership registry and the contract mapping are controls that live outside the statistic. Consensus can be jointly wrong, and this check will not tell you when it is. The operational fixture holds 24 deterministic decisions across 4 scenario groups. A clean control with an isolated error, the 0 deviation and inclusive floor boundaries, stale, and mismatched and commonly owned inputs, and split clusters with quorum loss after filtering. Python and TypeScript run the same fixture, the same policy, and the same invalid input gates. The tests also cover duplicate identifiers, timestamps that are not in coordinated universal time, invalid policy, future events, and exact boundary equality. Every one of those decisions reproduces in both languages. That proves definition-level parity. It does not prove market accuracy, predictive power, or investment value. You may have noticed there is no real provider disagreement in this lesson. That is deliberate, and the bar is high. A credible case needs contemporaneous raw snapshots from at least 3 independently owned sources. It needs redistributable licenses. It needs exact price semantics, clock lineage, and ownership as it was known on that date. And it needs a later authoritative correction or explanation. A single vendor interface cannot demonstrate cross-source consensus, and screenshots gathered at different moments cannot prove a simultaneous discrepancy. Until that evidence can be archived and redistributed, a named story would be anecdote presented as fact. So the 24 cases stay labeled synthetic. So the operating rule is a staircase, and every step comes before the next. Establish comparable contracts. Establish freshness. Establish independent ownership. Only then compute the center and the robust band. Make the zero deviation branch explicit, cap excessive dispersion, and recheck quorum on the inliers. When the evidence is insufficient or disputed, return no price and keep the reason. Keep the raw records, the registry version, the exclusions, the parameters, and the full diagnostic output, and never override an observation just because the check disagrees with it. The full price source consensus check article on the fintechbuilder.com carries the contract, the fixture, both implementations, the tests, and the interactive consensus lab. Continue with schema drift detector to protect the input contract this check depends on. Continue with the full price source consensus check article and the interactive consensus lab on the fintechbuilder.com. The article link is in the video description.